This is problem number 13. So let's look at it. It's a square root function, so I know the original square root function is down here at 0, 0, 1, 1, 4, 2. This is where my original function is. So let's write its table here. 0, 0, 1, 1, 4, 2. Alright, so the first thing I'm going to do is look to see where it's shifted. 1, 2. That's a horizontal shift. Two units to the right, and it's gone 1, 2, 3, 4 up. That's a vertical shift up 4 units. Okay, so that's your first two transformations. Now what I have to do is I have to figure out if these points right here on the original table are on this graph if I pretend that this is my new origin. So I'm going to pretend like this is 0, 0. Okay, and then I'm going to check to see if these points are on the table. Okay, so here's 0, 0. I'm going to go over 1, up 1. So that's the point 1, 1. I'm going to go over 4 and up 2. Over 4, up 2. These points are exactly the same. Same x and same y. So that means there's no stretch or compression. So all I have to do, if I was going to write this equation, okay, all I'd have to do is the horizontal shift and the vertical shift. There's no reflection here. There's no compression or stretch. Okay, no stretch or compression. Because if I was going to write this equation, I would say g of x is equal to the square root. We're going to shift to the right 2, so x minus 2 on the inside and up 4. Okay, this is just like problems 7 through 10, going through these transformations and putting them on in the equation. Okay, let's go ahead and do 14. Okay, number 14 looks like this. I know that's quadratic, so I'm going to do the same thing that here's my vertex right here, here's my regular quadratic function up here. Okay, and my table for this is negative 1, 1, 0, 0, 1, 1. That's these 3 points right here. And so I'm going to say 1, 2. So that's a horizontal. Let me see if I can make this so you can see it. That's a horizontal shift to the right 2. To the right 2 units. And then after I go right 2, I'm going to go down 3. So that's vertical shift. Down 3. Okay, so that takes care of that. My new origin, this is my pretend origin, 0, 0. So I'm going to go over 1, up 1, left 1, up 1. These 2 points right here are not on the graph. So I'm going to go over 1. This looks like a half to me. Over 1, that looks like a half to me, but I can't be absolutely positive. Okay, well, maybe I can be, because you see all these other little lines right here? That's a quarter, a half, so this is up 1/2. So I think I can be positive of that. So this is going to be negative 1, 1/2, 0, 0, over 1, to the right, a half. Okay, so since it's still on a grid line, and from here to here is just 1 unit, then this grid line right here is negative 2.5. That's really just a half. Okay, I hope that didn't confuse you. Okay, so my x values have stayed the same. My y values have been multiplied by half. So since the y's are being multiplied, that's a vertical. Now again, here's my original parent function right here. Okay, so I hope that you can see that if this came way up here like it's supposed to, that what I would be doing is vertically pushing down, pushing this down. So that's a vertical compression, and that's not going to fit on here, so let me get it over, by a factor of 1/2. And that's because I'm multiplying the y's by 1/2.